Okay, this is question 8 on the 2019 WJC additional maths paper. So in this question, we need to find the coordinates and nature of each of the stationary points on the curve, and there we have the equation. You must show all your working. Now, as soon as I'm dealing with stationary points, I like to do the same thing each time. So I like to write down my initial equation, 4x cubed minus 3x squared plus 20. I also want to write down my dy by dx. So let's differentiate it, which will give me 4 lots of 3x squared, so 12x squared, minus 3 lots of 2x is minus 6x, and a plus 20 differentiates to nothing. And then I also want to find my second derivative. So d2y by dx squared. So I'm going to differentiate this again. So my 12x squared differentiates to 12 lots of 2x, which is 24x. And my negative 6x will differentiate to negative 6. Okay, so I keep those all tucked away nice in a little corner. And then I start going about my question. So if I'm looking for the stationary points, the first thing I need to do is to find out where they are. So a curve is stationary when dy by dx, so it's not increasing and it's not decreasing if the gradient is 0. So I can put in my expression for dy by dx. Okay, I can put my dy by dx is 12x squared minus 6x. I can throw that in. So this becomes 12x squared minus 6x equals 0. I can divide everything by 6. That'll make things easier. 2x squared minus x equals 0. And then I have two terms, both of which have a common factor of x. So I can take x out as a factor. 2x minus 1. So I now have a product that gives me 0. The only way I can have a product to give me 0 is if something in the product is 0. So either the first term in the product, which is the x, is 0, in which case you'll have 0 multiplied by something, which will give me 0. Or the other thing in my product, the 2x minus 1, is 0, in which case I'll have something multiplied by 0, which again would give me 0. So I'm going to solve these equations. Well, the first one's already solved. I got x equals 0. On the second one, I'm going to add 1 to both sides. So I'd have 2x equals 1, and then divide by 2. X is going to be equal to a half. So that is the x-ordinate. I want the coordinate. So I need to find the y-ordinates that match up with these. So if x is 0, my y is going to be 4 lots of 0 cubed minus 3 lots of 0 squared plus 20, which is 20. So I have a stationary point of 0, 20. And then when x is a half, my y is going to be 4 lots of a half cubed minus 3 lots of a half squared plus 20. So I'm going to turn to my calculator for this one. So I get 4 lots of a half cubed minus 3 lots of a half squared plus 20. 79 over 4. So I have 0.5 or a half. I'd stick with a half. I'd rather have the fraction. So a half and 79 over 4. Okay, so they're my two stationary points. So those are the coordinates. Now I want to find out their nature. Okay, so the next part is to find out their nature. I've got the coordinates. Let's just sum that up. So stationary points are 0, 20 and a half, 79 over 4. Okay, so let's look at the nature. So in order to look at the nature of the stationary points, then I'm going to be looking at d2y by dx squared. Okay, so my d2y by dx squared is this one. So I'm going to look for 24x minus 6. Okay, so if I look at the first point, 0, 20, my value of x is 0. My second derivative is 24 lots of 0 minus 6, which is negative. So that means that my rate of change of the gradient is negative, which means that as I'm going, my gradient is becoming more and more negative. So if you imagine it starts off positive, as it becomes more and more negative, that means it becomes less and less positive until it gets 0, and then more and more negative is going to be like that. So we end up with a maximum. So whenever the second derivative is negative or less than 0, we know we have a maximum point, and that's the nature. And if I tried at the other point, so a half 79 over 4, then my second derivative is 24 lots of a half, which is 12, take away 6, is 6. Notice you have the symmetry there. This time, the rate of change of the gradient is positive. So as it moves on, the gradient is going to become more and more positive. So imagine it starts off negative, it becomes more and more positive, which means less and less negative until it becomes 0, and then becomes more and more positive and more and more positive again. So this ends up with a minimum. And that always happens if the second derivative is greater than 0. If it's positive, that means we have a minimum. So the key things that WJC are going to want to see is these things here. Okay, we need to show that it's less than 0. There's no point in saying it's -6, therefore it's a maximum. You need to state that it's less than 0, and also that this one's more than 0 to get a minimum.